Welcome. In this video, we'll continue preparing our dataset to be simulated in the GCBM by configuring and running the tiler. The first step when customizing a project and importing a new set of data is to configure the tiler Python script. This is the script that will convert our original spatial layers to the rasterized format that the GCBM expects. Go into sample_data_exercise \tools\tiler and open the tiler.py file. The first thing to do is update the bounding box. That's what defines the study area for the simulation, which the tiler script crops and reprojects all of the other spatial layers to match. On line 41, change inventory.shp to inv_sample.shp so that it is pointing to the new inventory input shapefile. We're going to change the attribute we're rasterizing. What that means is that it's going to look for all of the polygons that have a non-null value for the selected attribute to become the polygons we simulate. On line 42, change polyID to age, which corresponds to the age column in the shapefile. Finally, on line 43, we're going to change the pixel size from 0.00025 to 0.01 degrees. It's always a good idea to start a new simulation at fairly coarse resolution to make sure everything's up and running correctly. Any troubleshooting can also be done a lot quicker. When you're ready for the final simulation, you can always change the pixel size to something finer. The next thing that needs to be done is to configure the classifier layers. Again, that's what links the inventory to the yield table. In our original dataset, we had two classifiers, classifier 1 and classifier 2. In this new dataset, we just have the single leading species classifier. We'll go ahead and delete one of those classifiers and modify the remaining. On line 57, change classifier 1 to LDSPP, there are two occurrences, to correspond to the classifier used in the new inventory and growth curve files. These names will be important later on, so it's important that we get all the capitalization correct. The next thing that needs to be done is to update the file name. On line 57, change inventory.shp to inv_sample.shp. Next, we're going to configure the age layer. Initial age is a reserved name in the GCBM tool, which will ensure it gets automatically configured for us. Initial age stays the same. Again, we need to update the inventory shapefile name. On line 65, change inventory.shp to inv_sample.shp. Then, we need to make sure it's pointing to the correct attribute. On line 65, change age_2010 to age. The sample data also uses a new mean annual temperature layer in the nAmerica_mat_1971_2000.tiff file found in sample_data_exercise \layers\raw\environment. This time it's a raster file instead of a shapefile. As such, the existing temperature layer needs to be replaced in the tiler.py file. Note a simple raster layer example is located in the tiler_cheatsheet.txt file in the documentation folder. The result is that it's going to look a little bit different in our tiler script. Instead of using a vector layer, we're going to use a raster layer. There's a little Python cheat sheet included in this training package which has examples of some common layer formats that we run into. We now open up our tiler cheat sheet under sample_data_exercise, documentation, tiler_cheatsheet.txt. If you scroll down through that file, you can see examples of how to use the raster layers. We're going to use the first one, simple raster layer. The change we actually need to make is displayed here. Go back to tiler.py as we're going to change the vector layer to a raster layer. The first parameter here is going to be the file path. We will delete the first parameter, mean_annual_temperature. We just need to make sure the file path is correct. So layer underscore root right here is actually pointing to sample underscore data underscore exercise, layers, and the raw folder. From there, it's in the environment folder. This part is not case sensitive. And then we can copy our raster file name here. This comes to the last part of our file path, and we can delete all other items. The last step is to enter name equals mean annual temperature. It's another one of those reserved keywords in the GCBM that helps the mean annual temperature get configured in the right location. For the initial run of this new dataset, we will delete lines 73 to 87, as these are the disturbance events associated with the default project. We will add the new disturbance events later. Because Python is sensitive to whitespace, we'll need to make sure tabs and spaces are consistent in the script if you are using Notepad++. This step is optional depending on the text editor of your choice. Hit Ctrl and H to open the Replace window. We can type \T to replace 4 spaces. Make sure Extended is checked and select Replace All. We'll save the file and try running the tiler script. Go into sample underscore data underscore exercise \layers and find process underscore spatial underscore layers.bat. This batch file has a Python path at line 5. The path needs to match the one set up on your local machine. Run process underscore spatial underscore layers.bat. The tiler should only run for a few minutes and provide notification once completed. Upon successful completion, a collection of TIFF files as well as a set of JSON files should appear in the tiled folder in sample underscore data underscore exercise \layers. The TIFF files are the final cropped reprojected layers, and the JSON files contain metadata, including the attribute table. For example, if I open up this leading species JSON file, you can see the table of pixel values for all of the leading species names in the landscape. In the next video, we'll demonstrate how to run the simulation without disturbances in the GCBM.